imagine looking down at the Earth from very high above. Before we go any further, if you want a brand new Earth topic every single night to fall asleep to, subscribe. One tap and a new story is waiting for you every evening. What you see, almost no matter where you look, is blue. Deep, dark, shifting blue. The oceans cover more than 70% of this planet's surface. They are vast, beyond easy understanding, and most of what lies beneath them has never been seen by human eyes. That is not a small thing to sit with. We tend to think of the ocean floor as a kind of emptiness, a cold, dark place where nothing much has happened. But that picture is not quite right. The seafloor is a landscape of mountains and valleys, of wide, flat plains and sudden deep trenches. It holds more geography than all the dry land on Earth combined, and tucked into its shallower edges, in the places where the water is not so deep, there may be something else entirely. Something we have only begun to look for. There may be places down there where people once lived, not in the deep ocean, not in the crushing dark of the abyss, but in the shallows, in the places where the sea is only 10 or 20 or 30 meters deep. Places that were, not so very long ago in geological terms, dry land, coastlines where people built fires and raised children and left things behind, stones arranged in patterns, walls, floors, the quiet evidence of daily life. The ocean did not always sit where it sits today. That is one of the most important things to understand about this story. The level of the sea has changed many times over the long history of this planet. It has risen and fallen with the coming and going of ice ages. During the last great ice age, which reached its coldest point roughly 20,000 years ago, so much of the world's water was locked up in massive ice sheets that sea levels were more than 100 meters lower than they are right now. 100 meters. That is the height of a 30-story building. Whole coastlines that are now submerged were once open land, walked on, lived on, shaped by human hands. When the ice began to melt, the water came back. Slowly at first, then in surges. The coastlines that people had known for generations disappeared beneath the rising sea. What they left behind went with them, down into the water, covered by sediment and salt and time. some of those places may still be there. That is the question this episode will sit with quietly over the hours ahead. Not with urgency, not with alarm, but with the kind of slow, wondering curiosity that a question this old deserves. Which of the stone structures that divers and sonar equipment have found beneath the sea are genuine remnants of human settlement? Which are simply rocks shaped by nature into forms that only look like walls or roads or temples? And what might the ones that are real tell us about the people who built them? People whose names we will never know, whose languages vanished long before writing existed. The honest answer right now is that we do not know. Not fully. Underwater archaeology is still a young field. The tools for mapping the seafloor in detail have only existed for a few decades. Large stretches of shallow coastal water have never been properly surveyed. There are places off the coasts of India, Japan, Greece, Egypt, and many other countries where strange shapes sit on the seafloor. Shapes that have sparked genuine debate among researchers. Some scientists look at them and see the work of human hands. Others look at the same shapes and see nothing more than the ordinary geometry of fractured rock. Both views are serious. Both are held by careful people. The evidence, in most cases, is incomplete, and that is what makes this such a rich question to carry into sleep. It is not a question with a tidy answer waiting to be revealed. It is a question that opens outward the more you look at it, into deeper questions about who we are and how long we have been here, and how much of our own story we have simply lost, swallowed by the sea before anyone thought to write it down. The water is dark and quiet tonight. Somewhere beneath it, in the cold and the silt, something may be waiting to be found. Or it may be nothing at all. We do not yet know which. That is where we begin. Imagine standing on a beach at low tide. The wet sand stretches out ahead of you. The water pulls back, and for a moment, you can see the seafloor, the rippled sand, the small stones, the shallow pools. Then the tide comes in again, and all of it disappears beneath the surface. That small, daily rhythm is a tiny version of something much larger. Something that has been happening to our planet for millions of years. The ground beneath your feet is not permanent. never has been. The land we live on has been rising and sinking, flooding and draining, over and over again across deep time. What is ocean floor today was dry land once. What is dry land today was ocean floor before that. The boundary between land and sea is not a fixed line. It is more like a slow breath in and out over thousands and thousands of years. The reason for this comes down to ice. When the climate cools, water from the ocean evaporates, falls as snow, and builds up into enormous ice sheets on land. Those ice sheets can be miles thick, and because that water is now locked up on land as ice, the ocean level drops. The shallow coastal shelves, the gently sloping edges of the continents are exposed. They become dry land. Animals walk across them. Plants grow on them. And in time, people live on them. Then the climate warms. The ice melts. All that water flows back into the ocean. The sea level rises again. The coastal shelves flood. Whatever was there, the forests, the river valleys, the places where people built their lives, goes under the water. This is not a theory. It is something geologists and oceanographers have measured carefully. The last great ice age reached its coldest point roughly 20,000 years ago. At that time, sea levels were about 400 feet lower than they are today. 400 feet. That is taller than a 40-story building. Coastlines that are now far out at sea were once dry ground, open to the sky. The shallow continental shelves, those wide, gently sloping underwater platforms that rim the continents before the seafloor drops away into the deep, were enormous plains of exposed land. In some places, the exposed shelf stretched hundreds of miles beyond today's shoreline. The land area of the entire planet was significantly larger than it is now. As the ice age ended, the warming was not perfectly smooth or steady. There were long, slow periods of gradual rise. There were also faster pulses. Times when large sections of ice collapsed into the sea and water levels jumped in ways that would have been dramatic even within a single human lifetime. Some researchers estimate that during the fastest of these pulses, sea levels may have risen several feet per century. Others think the rises were slower. The exact rates are still being studied, and the evidence is incomplete. What this means for human history is something researchers are still working out. Modern humans have existed for at least 300,000 years. For most of that time, the coastlines looked very different from how they look today. The places where people are most likely to have settled, the coasts, the river mouths, the fertile lowlands near the sea, are now underwater. Some of the richest archaeological evidence of early human life may be sitting on the seafloor right now, covered in silt and salt and darkness. This is not a small idea. Roughly a quarter of the continental shelves around the world were exposed during the last ice age. That is an enormous amount of land, and almost none of it has been explored by archaeologists. The tools and methods for underwater excavation are difficult and expensive. Much of the shallow seafloor has never been mapped in detail. We are, in a very real sense, working with a partial picture. The ocean is not just a place where land used to be. It is an archive, a slow, cold, dark record of the world as it was. Stone does not rot the way wood does. Sediment can seal and preserve things that would crumble away on dry land. Some researchers believe the seafloor may hold evidence of human settlement that is better preserved than anything we have found on land. Others are more cautious, pointing out that wave action and currents can destroy structures just as easily as they can bury them. Both of those things may be true at once. Some sites may be remarkably well preserved. Others may be gone entirely. The question of what is actually down there waiting is one that researchers are only beginning to answer. And that answer, whatever it turns out to be, starts here, with the simple, quiet fact that the sea has not always been where it is now. There was a time, not so long ago in the deep calendar of the earth, when the world looked almost nothing like it does today. The coastlines were different. The seas were lower, and vast stretches of land that are now cold and dark beneath the ocean were once open ground, walked by people, shaped by wind, warmed by sun. To understand how so much land could vanish beneath the water, you have to go back to the ice. About 20,000 years ago, the Earth was locked in the grip of a glacial maximum, a time when enormous sheets of ice covered huge portions of the northern world. These ice sheets were not thin. They were miles thick in places. They pressed down on the land with unimaginable weight. And because so much of the world's water was frozen and piled up on the continents, the oceans were much shallower than they are now. Some estimates suggest sea levels were more than 400 feet lower than they are today. That is roughly the height of a 40-story building. Just sitting above where the waterline now rests. Think about what that means for the coastlines. Enormous shelves of land that are now submerged or simply dry ground. The shallow seas around Britain and northern Europe were a wide, open plain. The Persian Gulf was largely exposed. The coasts of India stretched much farther out into what is now open water. People could walk across land bridges that no longer exist. They did walk across them. We know this because we find their traces, stone tools, animal bones, the remnants of hearths, resting on the seafloor. Then the ice began to melt. The warming was gradual at first. Over thousands of years, the great ice sheets retreated. Meltwater poured into the oceans. Sea levels crept upward, slowly, and then, in certain periods, quite quickly. This process is called deglaciation, the slow release of all that frozen water back into the sea. It did not happen all at once. It came in pulses, in surges, in long, quiet stretches, followed by faster rises. One of the most discussed of these pulses is something researchers call meltwater pulse 1A, which may have occurred roughly 14,000 years ago. During this event, sea levels could have risen by as much as 40 to 60 feet in just a few centuries. That is an extraordinary rate. Coastlines that had been stable for generations would have shifted noticeably within a human lifetime. Some researchers believe this kind of rapid flooding is exactly the kind of event that could have driven coastal communities inland, leaving behind settlements that now rest far beneath the surface. But here is where the open question begins to deepen. We do not know exactly how fast these pulses moved in any given region. The rate of sea level rise was not uniform across the planet. Local geology, the weight of melting ice pressing down, and then releasing the land, ocean currents. All of these things shaped how quickly the water arrived in different places. Some coasts flooded slowly over centuries. Others may have changed much faster. The evidence is incomplete, and researchers continue to debate the timing and the pace. There is also a question about what people experienced during these changes. The communities that lived on these low coastal plains were not leaving written records. They were hunter-gatherers or early farming peoples, living close to the shore because the shore offered food, shelter, and trade. When the water rose, they moved. Some of them may have moved many times across many generations, always staying near the shifting edge of the sea. Their settlements, their fire pits, their middens, the ancient rubbish heaps where people discarded shells and bones and broken tools. All of these things were left behind as the water climbed. Some of those traces are still down there, preserved in cold sediment, sealed under layers of silt, resting in the quiet dark of shallow coastal seas. Archaeologists have found them. Stone tools recovered from the seafloor off the coasts of Britain, Scandinavia, and North America. Submerged peat beds that still hold the pollen of ancient forests. The bones of animals that no longer live anywhere near those latitudes. What we have not yet found, in most cases, is the full shape of the communities those people built. We find the scattered remnants. We find the edges. But the picture of what daily life looked like on those drowned coastlines remains mostly out of reach. The flood that covered all of this was not a single catastrophe. It was a long, slow transformation. And somewhere beneath the water, the evidence of it waits. There is a particular kind of coast that exists only in the memory of stone. Not the coast as it looks today, with its familiar lines of sand and cliff, but the coast as it was thousands of years ago, when the sea stood far lower and the land stretched out much farther than it does now. Those older shores are gone. The water took them, and what they were made of, the actual materials beneath people's feet back then, tells us something quiet and important about what might still be resting down there. Coastlines are not permanent things. They are built from whatever the land happens to offer at its edge. In some places, that means soft clay and river silt, the kind of ground that washes away quickly when the sea rises. In other places, the coast is made of harder stuff. Limestone, for instance, is a rock that forms slowly over millions of years from the compressed remains of ancient sea creatures. It is dense and pale and heavy. It does not dissolve easily. When a limestone coast goes underwater, it tends to stay intact for a very long time. This matters enormously for the question of what might survive beneath the sea. Sandstone is another common coastal material. It forms when grains of sand are pressed together under great weight and slowly cemented by minerals over time. Sandstone can hold a shape for thousands of years, even underwater, if the currents are gentle and the sediment is kind. Some of the structures found on submerged shelves around the world appear to be made of this kind of rock. Whether those shapes were carved by human hands or formed naturally is one of the central puzzles in underwater archaeology today. Granite is harder still. It is an igneous rock, meaning it was born from cooling magma deep inside the earth. Granite has been used in construction for as long as people have known how to work stone. It resists weathering. It holds its edges. If ancient builders used granite near a coast that later went underwater, the evidence could theoretically survive for a very long time indeed. The iron in that granite and in every rock on Earth's surface was not made here. It was forged inside stars that lived and died long before our sun was born. When those stars collapsed, they scattered heavy elements across space. Some of that scattered material eventually gathered into the cloud of dust and gas that became our solar system. The iron in the bedrock beneath an ancient coastline has been traveling for billions of years. It arrived here long before the first human ever stood at the edge of the sea. The water that covered those coasts has its own strange origin. Much of Earth's water is thought to have arrived very early in the planet's history, carried here by icy bodies from the outer solar system. Some researchers believe a significant portion came from asteroid impacts during a period called the Late Heavy Bombardment, roughly 4 billion years ago. Others think the water was already locked inside the minerals of the young Earth and slowly released over time. The question of exactly where Earth's oceans came from is still genuinely open. But whatever its origin, that water has been rising and falling across the land for as long as the planet has had a surface to cover. The minerals in coastal rock react slowly with seawater over time. Salt, which is mostly sodium chloride, works its way into tiny cracks. When temperatures shift, that salt can expand and contract, slowly breaking rock apart. This process, called salt weathering, is one reason why submerged structures can be difficult to identify. A wall that was once clean and sharp may look, after thousands of years underwater, almost indistinguishable from a natural rock formation. The edges blur, the corners round. The evidence becomes ambiguous. This is exactly why the debate over certain underwater sites is so difficult to settle. At the Yonaguni Monument off the southern coast of Japan, for example, researchers have looked at the same stone formations and reached opposite conclusions. Some see the flat terraces and sharp angles as signs of human shaping. Others point out that sandstone naturally fractures along straight lines and right angles when it erodes. The rock itself does not tell us which story is true. It simply sits there, patient and silent, in about 25 meters of water. The building blocks of a lost coast, the limestone and sandstone and granite, the salt and the iron and the ancient water, are all still present beneath the sea. They have not gone anywhere. They are waiting, as they have always waited, for someone to come and read them carefully enough. Whether we are reading them correctly is another question entirely. The seafloor is not still. It never has been. Beneath the cold and the dark, enormous forces are always at work, pressing and pulling, lifting and sinking, reshaping the bottom of the ocean in ways that take thousands of years to see, but never truly stop. One of the quietest of these forces is the weight of ice. During the last great ice age, vast sheets of glacial ice, some of them more than a mile thick, sat on top of the land across the northern parts of the world. That ice was heavy beyond easy imagining. It pressed down on the rock beneath it the way a hand presses into soft clay. The land actually sank under the load. When the ice melted, the land slowly began to rise again. This process has a name: isostatic rebound. It is still happening today in places like Scandinavia and Canada, where the land is quietly lifting a few millimeters every year, still recovering from a weight it lost more than 10,000 years ago. But here is where the mystery deepens. While some land was rising, other land was sinking. The water from all that melted ice had to go somewhere. It poured into the oceans. The ocean basins filled and grew heavier. That extra weight pressed down on the seafloor, which in turn pushed against the edges of the continents. Some coastlines that had been rising found themselves being nudged downward by the new pressure of all that added water. The forces at work were not simple or uniform. They pulled in different directions in different places, and the result was a world of coastlines that shifted in complicated and uneven ways. Tectonic forces added their own slow pressure. The great plates of the Earth's crust, those enormous slabs of rock that carry the continents and the ocean floors, are always moving. They grind against each other, pull apart, or slide beneath one another in a process called subduction, where one plate dives under another. The seafloor can drop suddenly and dramatically. Where plates pull apart, new rock wells up from below, and the seafloor spreads outward. These movements are measured in centimeters per year, but over thousands of years, they add up to enormous changes in the shape of the ocean bottom. For underwater archaeologists, this creates a genuine problem. A stone structure on the seafloor might have sunk because the sea level rose around it, or it might have sunk because the ground beneath it subsided, pulled downward by tectonic forces, or by the simple compression of soft sediment under its own weight. Or it might never have been above water at all. Distinguishing between these possibilities is not easy. The evidence is often incomplete, and the forces involved leave similar marks on the rock. Sediment is another force entirely. Rivers carry fine particles of sand and silt down to the coast and out into the sea. Over centuries, that sediment builds up on the seafloor in layers. It buries whatever lies beneath it, slowly and completely. A stone wall, a hearth, a carved step, all of it can disappear under meters of soft mud in a few thousand years. In some ways, the sediment preserves what it covers, protecting it from currents and from the slow chemical work of salt water. In other ways, it hides the evidence so thoroughly that even the best sonar equipment can only hint at what might be below. Some researchers believe that sediment burial is one reason we have found so little. The submerged coastlines of the world are not bare rock shelves waiting to be explored. They are, in many places, blanketed under layers of material that accumulated over millennia. What lies beneath those layers is genuinely unknown. One theory holds that entire settlement sites are preserved in near-perfect condition under the mud, sealed away from oxygen and decay. A competing view suggests that the same sediment layers have been disturbed by underwater currents and shifting sands over thousands of years, scattering and mixing whatever was once there, until it is no longer recognizable as a site at all. The seafloor, then, is not a simple archive. It is a place where multiple forces have been working at the same time, in the same space, often in opposite directions. Ice pressed down and then lifted away. Water rose and added its own weight. Tectonic plates shifted beneath everything. Sediment settled over the top of all of it. The result is a record that is partial, layered, and deeply difficult to read. What the seafloor remembers, it does not give up easily. And what it has forgotten entirely, we may never recover. The forces that shaped it are still at work tonight, pressing quietly in the dark. Somewhere off the southern coast of Japan, in water about 5 to 10 meters deep, shallow enough that a tall person could almost stand, there are stone formations that have puzzled researchers for decades. The water is clear and blue-green. The stones are pale and angular, and the question of what they are has never been fully settled. The Yonaguni Monument, as it has come to be called, sits near the island of Yonaguni at the far western edge of Japan. It was first noted by divers in the 1980s. What they found were broad, flat terraces, sharp right-angle corners, and what appear to be steps cut into solid rock. Some of the individual stone faces run nearly 8 meters high. That is about as tall as a 2-story house, rising straight up from the seafloor. Now, picture a building the size of a large school gymnasium, Then imagine it carved from a single piece of rock. That is roughly the scale of the main structure at Yonaguni. It stretches about 50 meters across. Some researchers believe it was shaped by human hands, perhaps 10,000 years ago or more, when sea levels were lower, and this rock sat above the waterline. Others believe it is entirely natural that the local rock, a type of sandstone called mudstone, simply fractures in straight lines and right angles when it erodes. Both views have serious supporters. Neither has fully won the argument. This is one of the strange things about searching for lost settlements beneath the sea. The ocean does not make it easy to tell the difference between what people built and what the earth made on its own. Stone is patient. It holds its shape for thousands of years, but it also breaks and splits in ways that can look, at a glance, surprisingly geometric. To understand the scale of what might be hidden, it helps to think about numbers in a physical way. Since the last ice age ended, roughly 20,000 years ago, sea levels around the world have risen by about 120 meters. 120 meters. If you stacked 40 adult humans on top of each other, that is roughly the height of water that now covers what was once dry land. Coastlines that people walked on, fished from, and possibly built upon are now buried under that much ocean. The total area of land swallowed by the sea since the ice age is enormous. Some estimates suggest it is close to 27 million square kilometers. That is roughly the size of North America. An entire continent's worth of former coastline, now underwater. Most of it has never been surveyed. Most of it never will be, at least not with the tools we have today. When you hold that number in your mind, the idea that some of what lies down there might be the remains of human settlement stops feeling unlikely. It starts to feel almost expected. Off the coast of India, in the Gulf of Combat, Sonar surveys in the early 2000s picked up what some researchers described as geometric structures on the seafloor. Walls, grids, what looked like the outlines of a city. The water there is about 40 meters deep. If the structures are real and man-made, they would be among the oldest known settlements ever found, possibly older than 9,000 years. but the evidence is genuinely contested. The sonar images are difficult to interpret. Sediment in the Gulf is thick and murky. Some scientists believe the shapes are natural formations or sonar artifacts, distortions caused by the equipment itself. Others believe the site deserves much more careful study. The question remains open. What makes these shallow water sites so compelling is exactly their scale. They are not tiny. They are not fragments. If the structures at Yonaguni were shaped by people, they represent a significant effort, organized labor, planning, tools. If the patterns in the Gulf of Combat are real, they suggest a settlement that covered a wide area. These would not be small camps or temporary shelters. They would be places where communities lived, worked, and built things meant to last. And yet the ocean keeps them just out of reach. The water is murky. The currents are strong. The sediment shifts. A stone wall that was clear in one dive might be half buried the next season. Researchers work slowly, carefully, with limited time and limited air. The scale of what we might be missing is genuinely hard to hold in the mind. An entire continent's worth of former coastline, structures the size of buildings, sitting in water shallow enough to swim in. And still, so many questions without answers. Picture a city at the edge of the sea. Not the sea as it is today, but the sea as it was a very long time ago, when the water sat much lower and the coastline stretched far out beyond where the waves now break. The land was wide and open. The air would have carried salt, the way it always does near the ocean. And people built their lives there, right at the boundary between solid ground and moving water. That edge is one of the most useful places a community can choose. Fresh water often runs down to the coast from inland hills. Fish gather in the shallows. Boats can carry goods from one place to another far faster than any path through dense forest. So again and again, across thousands of years, people chose to build close to the water. They built storage rooms and cooking fires and walls of stacked stone. They built docks and channels and places to dry their nets. They built everything a community needs, and they built it right there at the edge. What would it have looked like to stand in one of those places. The ground underfoot would have been firm, perhaps sandy in some spots, rocky in others. The buildings would have been low and close together, the way early settlements tend to be. Stone walls, where stone was available, would have caught the morning light and held warmth through the cooler evenings. The smell of the sea would have been constant. The sound of it, too, a low and steady rhythm just beyond the last row of houses. Some of those places are now underwater. The sea rose, slowly at first and then faster, and the edges of the land went with it. The buildings did not disappear all at once. They sank gradually, the way a sandcastle sinks when the tide comes in, except the tide in this case took centuries. Walls that once stood in open air now stand in dim, cold water. The stone is covered in a pale crust of marine growth, soft corals and sea moss, and the tiny shells of creatures that have made their homes on surfaces that were once dry. When divers descend over a site like this, the first thing they often notice is the color. The water filters out the warm reds and oranges within the first few meters of depth. What remains is a world of blue and green and gray. The stone walls below take on a cool, muted tone, almost the color of old pewter. The edges of the blocks, if they were cut by human hands, tend to be sharper than the surrounding rock. Natural stone breaks in curves and angles that follow the grain of the earth. Worked stone, stone shaped by a tool, tends to have flatter faces and more deliberate corners. That difference, subtle as it is one of the things researchers look for. But the difference is not always easy to see. This is part of what makes underwater archaeology so difficult and so genuinely unresolved. Some formations that look like walls are simply layers of sedimentary rock, the kind that splits naturally into flat sheets and stacks up in ways that can resemble construction. The seafloor is full of shapes that seem intentional but are not. Researchers disagree, sometimes strongly, about which structures belong to which category. The Yonaguni Monument off the southern coast of Japan is one example that has been debated for decades. Some researchers look at its terraced steps and flat platforms and see the work of human hands. Others look at the same stone and point to the natural fracture patterns of sandstone, which can produce exactly those shapes without any tool ever touching them. Neither side has fully convinced the other. Pavloptri, off the southern coast of Greece, is a different kind of case. There, the structures are clearly the work of people. Streets and building outlines and what appear to be storage areas have been mapped in careful detail. The site sits in shallow water, close enough to the surface that the light still reaches it on a calm day. From above, in the right conditions, the outlines of the ancient town are visible through the water, pale and quiet, like a drawing made in stone on the seafloor. That image stays with you. A whole town, preserved not in a museum, but in the sea itself, still roughly where it stood when people lived in it. The walls are worn. The rooms are open to the water, but the shape of the place remains. The shape of the life that was lived there at the edge, before the edge moved. What other shapes are waiting in the shallows, just beyond where anyone has thought to look? Beneath the water, beneath the sand, beneath layers of silt that have settled for thousands of years, there are things waiting to be found. Not all of them are visible. Not all of them are easy to reach. Some of the most important clues about lost coastal settlements are buried so deeply that even a diver swimming directly above them would have no idea they were there. This is one of the quiet challenges of underwater archaeology. The sea does not simply preserve things. It buries them, shifts them, covers them in sediment, that slow-settling mixture of fine sand, clay, and organic material that drifts down through the water column over centuries. In some places, this burial is actually a gift. Sediment can seal objects away from oxygen and from the organisms that would otherwise break them down. Wood, bone, and even plant material have survived for thousands of years in waterlogged, oxygen-poor mud. But that same burial makes discovery extraordinarily difficult. Researchers working in shallow coastal waters sometimes use a tool called a sediment core. It is a long, hollow tube pushed down into the seafloor to pull up a column of layered material. Each layer represents a different period of time. The deeper the layer, the older it is. When and those cores contain charcoal or pollen from plants that no longer grow in the region, or fragments of worked bone. It tells researchers that people were once living on that spot. The land was dry. Fires were burning. Someone was there. The trouble is that a sediment core is a very small sample of a very large area. Finding meaningful material in one core does not mean researchers know what surrounds it. It is a little like finding a single tile and trying to imagine the floor it came from. The shape of the whole picture remains unknown. Salt water adds its own complications. Salt is corrosive. Over long periods, it breaks down metals, softens stone, and dissolves the kinds of organic materials that might otherwise survive. Some objects that would be well preserved in a freshwater lake or a peat bog simply do not last as long in the open sea. This means that what survives in a submerged coastal site is often uneven. A stone wall might remain, while the wooden roof above it has long since disappeared. A ceramic pot might survive, while the cloth stored inside it has vanished entirely. Researchers are left with fragments, and they must try to reason carefully about what those fragments once belonged to. There is also the question of movement. The seafloor is not still. Currents shift sediment. Storms stir up the bottom in shallow water. Objects that were once in one place can be carried some distance over centuries. This makes it harder to say with confidence that a particular artifact was used at a particular location. One theory holds that some of the scattered stone tools found in shallow coastal waters were carried there by currents from sites further inland, now much deeper. Another view suggests that the density and distribution of certain finds, clustered in ways that look deliberate, points to actual habitation rather than random drift. The debate is genuinely open. Deeper water brings a different set of challenges. Below about 30 meters, roughly 100 feet, recreational diving is no longer practical. Researchers need specialized equipment, remotely operated vehicles, or submersibles. These tools are expensive and not widely available. Much of the shallow continental shelf, the broad underwater plain that extends out from most coastlines before dropping away into the deep ocean, has never been systematically surveyed. The areas that have been examined are often those near known historical sites, or places where fishermen have accidentally pulled up unusual objects in their nets. Those accidental finds have sometimes been remarkable. Anchors, statues, fragments of carved stone, and pieces of pottery have all come up in fishing nets over the years, pointing to submerged sites that were never intentionally searched for. Each one raises a question that cannot yet be answered. How large was the site? How old? Was it a settlement, a harbor, a single building, or something else entirely? The mud and salt of the seafloor hold these questions quietly. They do not give up their answers easily. Researchers can spend years working a single small area and still come away with more questions than conclusions. The tools are improving. Sonar mapping, underwater drones, and new methods of analyzing sediment cores are all making it possible to see more than before. But the ocean floor is vast, and the work is slow, and the layers go very deep. Somewhere beneath all of that settled silt, there are almost certainly things that would change what we understand about early human life on this planet. Whether we will ever find them, and what they will tell us when we do, remains one of the quieter, open questions of our time. There is a rhythm to the sea that most of us never notice. It is not the rhythm of waves, though those are real enough. It is something far slower, a pulse that takes thousands of years to complete a single beat. The ocean rises. The ocean falls. It has done this many times before, and the coastlines of the world have shifted with it, again and again, like a slow breath drawn in and slowly let out. We are living in one particular moment of that breath. Right now, the sea sits at a level that would have seemed impossibly high to people who lived here 20,000 years ago. Back then, so much of the world's water was locked inside enormous ice sheets that the ocean sat roughly 400 feet lower than it does today. Entire shelves of land were exposed. Broad plains stretched out where we now sail ships. People walked across them, built on them, and in some cases may have raised harbors along their edges. A harbor is a very specific kind of place. It is not just any stretch of coast. It is a sheltered bay or inlet where boats can rest safely from the open water. Building one takes time and effort. Communities plan harbors carefully. They choose locations where the land curves just right, where the water is calm, where the depth is useful but not too deep. A harbor, in other words, is a sign of settled life. It is a sign that people stayed long enough to shape their surroundings. Some researchers believe that many of the best natural harbors of the ancient world are now underwater. The logic is straightforward. People tend to settle near calm, protected water. The most sheltered bays and inlets often sit at the edges of continental shelves, in the zones that were exposed during the last ice age, when the ice melted and the sea rose. Those same sheltered places would have been among the first to flood. The very features that made them attractive to ancient communities also made them vulnerable to rising water. What this means, if the theory holds, is that some of the most important early ports in human history may be sitting on the seafloor right now, silted over, quiet, untouched for thousands of years. There is a competing view worth sitting with. Some geologists point out that natural processes can create features that look remarkably like worked harbors. Erosion carves curved bays. Shifting sediment builds up into what looks like a breakwater. The low wall that shelters a harbor from waves. Underwater rock formations can mimic the shape of a constructed quay. The flat-edged platform where boats once tied up. Without careful excavation and analysis, it can be genuinely difficult to tell the difference between a harbor that humans built and a coastline that simply looks like one. This uncertainty is not a failure of science. It is an honest reflection of how hard the question is. Underwater archaeology is slow, expensive, and physically demanding. Visibility in shallow coastal waters is often poor. Sediment covers everything. A site that might take a few weeks to survey on dry land can take years to study beneath the sea. Still, some sites offer tantalizing hints. Off the coast of India, in the Gulf of Combat, sonar surveys have picked up what some researchers describe as geometric structures on the seafloor. Straight lines, right angles, features that look, to some eyes, like the outlines of a planned settlement. Others look at the same data and see natural formations shaped by strong underwater currents, which are known to be powerful in that region. The debate continues, and no firm conclusion has been reached. The site at Pavloptri, off the southern coast of Greece, is somewhat clearer. There, in shallow water, lie the remains of a Bronze Age town. Streets, walls, and what appear to be harbor structures are visible and have been carefully mapped. Pavloptri did not sink dramatically. It subsided slowly over centuries as the land beneath it settled. Its harbor, if it had one in the full sense, is now a few meters below the surface of the Aegean Sea. What Pavloptri suggests is that the cycle of rise and fall does not always happen in a single catastrophic moment. Sometimes the sea takes a town slowly, a little more water each generation. A harbor that once welcomed fishing boats gradually becoming too shallow, then too deep, then simply gone from living memory. The rhythm of the ocean is patient in a way that human lives are not. It does not hurry. It does not announce itself. It simply continues as it has for millions of years, pressing forward and pulling back, reshaping every coast it touches, hiding what was there before. There is something quietly strange about a road that ends at the water's edge and keeps going. You can find them in several places around the world. Old stone paths, worn smooth by feet that walked them long ago, leading down a beach or a cliff and disappearing beneath the surface. They do not stop at the shoreline. They continue as if the sea were not there at all, as if once it was not. This is one of the quieter puzzles in underwater archaeology. Not the dramatic ruins of a sunken city, but something simpler and in some ways more unsettling. A road that was built to go somewhere, and that somewhere is now underwater. Along the coastlines of Britain and Ireland, researchers have documented what appear to be ancient trackways, paths made of stone or compacted earth that run from dry land straight into the sea. Some of these are found in intertidal zones, the strips of shore that are exposed at low tide and covered at high tide. Others extend further out into water that has not been shallow for thousands of years. The people who built them were not building roads to nowhere. They were building roads to somewhere that is gone. One possibility is that these paths connected settlements on what is now dry land to other settlements, or to resources on land that has since been swallowed by the sea. Think of Doggerland, the broad plain that once filled the southern North Sea. At its peak, during the last ice age, it was home to rivers, wetlands, and forests. People lived there. They hunted, fished, and moved across it. And they almost certainly built paths. Some researchers believe the trackways found along the British coast may be the surviving ends of much longer routes that once crossed Doggerland entirely. But this is not certain. Other researchers suggest some of these features are natural. Certain rock formations, especially in areas with layered sedimentary stone, can produce long, straight ridges that look remarkably like constructed paths. The debate between natural formation and human construction runs through almost every underwater stone feature, and these trackways are no exception. Without clear evidence of tool marks, deliberate shaping, or associated artifacts, the question stays open. What makes the roads particularly interesting is what they imply about the world around them. A road is not built in isolation. Roads connect things. They connect homes to fields, villages to markets, fishing camps to the open shore. If a road leads into the water, then something on the other side of that water was once worth traveling to. The road is a kind of arrow pointing toward a lost place off the coast of India, near the ancient city of Dwarka. Divers have found what some researchers describe as stone structures and paved surfaces extending into the Gulf of Combat. Some of these features appear to align with the modern city's layout in ways that suggest continuity, as if the city simply continued outward onto land that is now submerged. One theory holds that Dwarka was once much larger, spreading across a coastal plain that was gradually flooded as sea levels rose after the last ice age. The roads and paths found underwater might be the outer edges of that older, larger city. Others are more cautious. The Gulf of Combat has strong currents and poor visibility, which makes detailed survey work difficult. Some geologists argue that the structures could be natural rock formations shaped by those same currents over thousands of years. The evidence they say, is not yet strong enough to draw firm conclusions. Both views have serious researchers behind them, and neither has fully convinced the other. There is also the question of what lies between the roads. A road implies neighbors. It implies the fields, the buildings, the wells, the hearths that the road was built to serve. If the road is real, then somewhere nearby, under the same water, there should be more. Finding the road is, in a way, only the beginning. It points toward everything else that might still be waiting. This is part of what makes underwater archaeology so patient a science. You find one thread and it leads to another. A road leads to a harbor. A harbor leads to a settlement. A settlement leads to a whole way of life, preserved in silt and salt, waiting for someone to look carefully enough. For now, the roads lead into the water and stop. Or rather, they do not stop. They continue somewhere below the surface toward places we have not yet found. The question of where they go and what was once at the other end stays open and quiet, like the water itself. Some of the most remarkable underwater sites on Earth are not just walls or roads or scattered stones. They are places that seem to have been built with great care and great intention. Places where the architecture, if we can call it that, suggests something more than simple shelter. These are the extremes of what the sea has swallowed. The oldest, the deepest, the most elaborate, the most debated, and in almost every case, the question of what they truly are remains beautifully, stubbornly open. Consider Pavloptri, off the southern coast of Greece. It sits in shallow water, only about 4 meters down, which is shallow enough that local fishermen have known about it for generations. But when researchers began mapping it carefully, they found something that stopped them quiet. Street plans, building foundations arranged in clear patterns, courtyards, what appear to be graves. The site stretches across roughly 30,000 square meters of seafloor, and some of the structures may date back 5,000 years or more, placing them among the oldest known submerged town remains anywhere in the world. That is not a theory. The stonework is there. The layout is there. What remains open is the full picture of who lived there, how large the community was, and exactly when the sea finally covered it. Then there is Dwarka, in the Gulf of Combat, off the western coast of India. Here the water is murky, and the currents are strong, which makes diving difficult and evidence hard to read. Researchers have reported finding geometric stone structures, what may be walls and foundations, resting on the seafloor. Some have suggested these remains could be extraordinarily old, possibly stretching back 9,000 years or more. That would make them among the oldest human constructions ever found anywhere. But other researchers urge caution. The visibility is poor. The artifacts recovered from the site have been difficult to date with certainty, and some geologists suggest that natural processes in that region can produce shapes that look worked but are not. The debate is genuine, and it has not been resolved. The Yonaguni Monument off the southern tip of Japan is perhaps the most dramatic example of this kind of disagreement. The structure rises from the seafloor in a series of flat terraces, sharp angles, and what look like steps carved from solid rock. Some researchers look at it and see clear evidence of human shaping. The angles are too precise, they say. The flat surfaces too regular. Others look at the same stone and point to the way sandstone naturally fractures along clean lines, producing shapes that can look almost architectural without any human hand involved. Both sides have examined the same site. Both sides hold their position. The monument sits in about 27 meters of water, and it has been photographed and measured many times. And still, no consensus has formed. What makes these extreme cases so compelling is not just their age or their depth. It is the scale of what they suggest. If Dwarka's deepest structures are as old as some researchers believe, then people were building organized settlements along that coastline during a period when much of the world's population was still living in small, mobile groups. If Yonaguni was shaped by human hands, then someone was doing careful stonework in that part of the Pacific far earlier than most timelines allow. These are not small claims. They would ask us to rethink what we know about early human capability and early human settlement. And then there is Heraclean, known also also as Thanis, which sank into the sea off the Egyptian coast. Unlike Yonaguni or Dwarka, there is no real debate about whether Heracleion was a human settlement. Ancient texts described it. Statues, coins, and inscriptions have been pulled from the mud. It was a major port city, and it sank, likely due to the slow liquefaction of the waterlogged sediment it was built on, sometime around the 8th century. What makes it extreme is its preservation. Enormous statues, some of them several meters tall, lay face down in the silt for over 1,000 years before anyone found them again. The mud kept them almost perfectly intact. Each of these places sits at a different extreme. One is the oldest. One is the most contested. One is the most intact. One is the most dramatic in its geometry. Together they form a kind of outer edge of what underwater archaeology has found so far. And the thought that sits quietly underneath all of it is this: if these are the sites we have found in the small fraction of the seafloor that has been carefully examined, then what might still be waiting in the parts we have not yet looked at closely? The answer, for now, is simply that we do not know. Sometimes the most revealing things are the smallest ones. A stone wall can be argued about for decades. Researchers on one side say the angles are too sharp, the corners too clean for nature to have made them. Researchers on the other side point to known geological processes that produce surprisingly straight lines and flat surfaces. The debate goes on, but a hand tool is harder to argue with. A grinding stone worn smooth in the middle, shaped by 10,000 small circles of human effort, carries a kind of quiet certainty that a wall cannot always offer. Divers working the shallows off the coast of India, in the Gulf of Combat, have reported pulling up objects that look very much like worked stone tools: scrapers, blades, pieces shaped in ways that suggest a deliberate hand. The sediment around them has been dated in some studies to a remarkable age, possibly older than most people imagine when they think of early civilization. But the dating is contested. Some researchers question whether the objects were truly found in undisturbed layers, or whether currents and shifting sands had moved them over time. The the tools themselves are suggestive. The context around them is harder to read. This is one of the central puzzles of underwater archaeology. On dry land, a tool found in a particular layer of soil tells you something reliable about when it was left there. Underground, the layers stay mostly still. But on the seafloor, especially in shallow coastal waters, things move. Storms push sediment. Currents carry objects far from where they started. A tool that looks ancient may have drifted from somewhere else entirely. Or it may be exactly where it was dropped thousands of years ago by someone who never imagined the sea would swallow that spot. At Pavloptri, the submerged site off the southern coast of Greece, the picture is a little clearer. The ruins there sit in relatively calm, shallow water. Pottery fragments have been found scattered among the stone structures, small pieces of fired clay, some painted, some plain. Pottery is useful to archaeologists because different styles and techniques belong to different periods. The shapes of handles, the thickness of walls, the patterns pressed into wet clay before firing. These small details act like a clock. Some of the pottery at Pavloptri suggests the site was used across a very long stretch of time, from the Bronze Age back even further, though the full picture is still being pieced together. What strikes many researchers is not just the age of these objects, but their ordinariness. These were not ceremonial pieces. They were everyday things: bowls for food, vessels for water or oil, the kind of objects that fill any kitchen in any era. Finding them on the seafloor, still resting near the outlines of the rooms they once belonged to, creates a strange and quiet feeling. Someone used that bowl. Someone set it down. And then the water came. Grinding stones appear at several underwater sites. They are among the most durable objects early people made, and among the most universal. Nearly every culture that processed grain or pigment or dried plant material used some version of a grinding stone. When divers find them on the seafloor, worn smooth in the center from long use, they carry a kind of physical memory. The weight of the stone, the curve worn into it by repetition. These are the traces of daily life, not grand monuments. Some of the most delicate finds are the ones made of organic material that somehow survived. Waterlogged wood, preserved by cold or low oxygen conditions on the seafloor, occasionally holds tool marks. The angle of a cut, the width of a blade, the pattern of repeated strokes. These details can tell researchers something about the tools used to shape the wood, and sometimes about the people who used them. Organic material rarely survives on land for thousands of years, but certain underwater conditions act almost like a slow refrigerator, slowing the decay that would otherwise erase everything. The challenge is always the same. Each small object raises a question that the object alone cannot answer. Who made this? Where did they come from? How long did they live in this place before the water took it? The tools suggest skill, routine, a life built around repeated tasks. They suggest people who planned ahead, who maintained their equipment, who passed techniques from one generation to the next. But the full story of those people, where they went, what they knew, what they believed, remains somewhere beneath the silt. The small things survive. The larger story is still waiting to be read. For a long time, no one was looking. The idea that whole stretches of coastline had drowned beneath the sea was not something most people thought about. The ocean was the ocean. The land was the land. The line between them seemed fixed, permanent, something that had always been exactly where it was. It took a slow accumulation of strange discoveries, spread across many decades, before anyone began to suspect that the line had moved, and that it had moved a great deal. The earliest clues came not from divers or explorers, but from fishermen. This is often how it begins. A net dragged across the seafloor comes up heavier than expected. Something has snagged it. The fisherman hauls the net aboard and finds, tangled in the mesh, something that does not belong to the sea. A piece of dark, dense wood, a fragment of bone, a shaped stone with a smoothed edge. These things were pulled from the waters off the coasts of northern Europe for centuries before anyone thought to ask what they meant. In the North Sea, fishermen working the shallow banks between Britain and what is now the Netherlands had been pulling up strange objects for generations. Antlers, teeth from animals that no longer lived in the region. Occasionally, pieces of what looked like peat, that dark, spongy material that forms when plants decay slowly in wet ground. Peat does not form underwater. It forms on land. Its presence on the seafloor was a quiet puzzle that most people simply set aside. It was not until the late 19th and early 20th centuries that geologists began to piece together what these objects might mean. Researchers studying the shape of the seafloor noticed that the shallow banks of the North Sea looked, in some ways, like a drowned landscape. There were what appeared to be old river channels running across the bottom. There were gentle ridges and valleys that matched the kind of terrain you might find on a low, flat plain. Slowly, a picture began to form. The land that is now underwater had once been dry. The rivers had once flowed across it. The animals whose bones the fishermen were finding had once walked on it. This was the beginning of what we now call Doggerland. That vast, low-lying plain that connected Britain to continental Europe during the last ice age, when sea levels were much lower than they are today. But for a long time, even after researchers began to suspect it had existed, there was very little direct evidence of people having lived there. The bones and the wood and the peat suggested land. They did not yet suggest human habitation. That changed gradually as more objects came up in the nets. Stone tools appeared. Worked flints, flint that had been shaped by human hands into cutting edges and scrapers. A few pieces of what may have been wooden implements. These were not the kinds of things that form naturally on a seafloor. Someone had made them. Someone had held them. The question was when and who, and what their lives had looked like on that now vanished plain. The challenge for early researchers was enormous. They had no way to dive to the seafloor and look directly. They had no sonar, no submersible cameras, no remote sensing tools. All they had were the objects that chance brought to the surface, and the slow work of comparing those objects to things found on land. Dating methods were limited. The context of each find, where exactly on the seafloor it had come from, what surrounded it, was almost always lost the moment a net dragged it free. This is one of the deep frustrations of underwater archaeology, and it was felt sharply by the earliest researchers in the field. A stone tool pulled from the sea tells you that someone was once nearby, but it does not tell you where they lived, how long they stayed, or what happened to them. The net erases the context. The find survives, but the story around it does not. Some researchers argued that this made underwater finds nearly worthless as evidence. Without context, a tool is just a tool. You cannot reconstruct a settlement from a single scraper pulled up in a fishing net. Others disagreed. They argued that even isolated finds, mapped carefully and dated when possible, could begin to sketch the outline of a lost world. The debate over how much weight to give these decontextualized objects, objects stripped of their surroundings by the act of recovery, continued for decades, and in some ways it continues still. What the fishermen's nets had started, science would slowly try to finish. But finishing it would require tools that did not yet exist. There is something most people never think about when they imagine a sunken city. They picture the stones, the walls, the old harbor steps disappearing into green water. But there is something else that went under with those places, something you cannot see on any sonar scan, something no diver will ever hold in their hands. Language went under too. When a coastline floods, it does not only swallow buildings, it swallows the words people used to describe that place. The names of rivers, the names of bays, the words for the kinds of fish that schooled in the shallows, the songs sung at the water's edge. All of it gone, or nearly gone, with the land itself. This is one of the quieter surprises of underwater archaeology, and it raises a question that even linguists, people who study the history of language, find genuinely strange. How much of what we do not understand about ancient languages might be explained by the fact that the places those languages described no longer exist above water. Some researchers have begun to wonder about this seriously. They point out that many of the oldest known languages contain words with no clear origin. Words that seem to have no relatives in any neighboring tongue. One idea is that some of these orphaned words came from coastal communities whose homelands are now submerged. The people survived. They moved inland. They carried their words with them. But the land those words described was gone, And so the words slowly lost their meaning and faded. This is not a settled theory. Other linguists argue that orphaned words have many explanations. Languages borrow from each other in ways that are hard to trace. Words can shift in meaning over centuries until their origins become invisible. The idea that lost coastal lands explain linguistic mysteries is intriguing, but the evidence is thin and the question remains open. Still, the thought is hard to let go of entirely. Consider what happens to a language when its geography disappears. Imagine a word that means something like the sandbar where the seals gather in autumn. That word is useful, even essential, to the people who live near that sandbar. But if the sandbar floods and the community scatters, the word has no home. It becomes a sound without a referent. Within a few generations, it is gone. Linguists have a name for this kind of loss. They call it language death by geography. It is not common in the modern world, but in the deep past, when sea levels were rising fast and coastlines were shifting within living memory, it may have happened again and again. There is a related idea that some researchers find even more striking. A number of coastal place names in Europe and the Middle East appear to be very, very old. Far older than the written records that contain them. Some scholars think certain names along the Atlantic coast of Europe may preserve sounds from languages spoken before the last great flooding, thousands of years ago. These are called substrate words, traces of an older tongue that survived inside a newer one, the way a fossil survives inside a rock. But this idea is contested too. Proving that a word is ancient is extraordinarily difficult. Languages change in ways that are hard to reverse engineer. What looks like a prehistoric survival might simply be a coincidence of sound. The honest answer is that we do not have the tools yet to know for certain. What we do know is this: when Doggerland, that wide, low plain that once connected Britain to the European continent, flooded after the last ice age, it was not empty. People lived there. They had names for the hills and the rivers and the marshes. Those names are gone now. We have no record of them. We never will. The same is true of the drowned coasts of India, of the submerged plains off Japan, of the shallow seafloor that once edged the Mediterranean. All of those places had people. All of those people had words. And nearly all of those words vanished with the water. There is something quietly astonishing about that. The ocean did not just take the buildings. It took the stories those buildings were built inside. It took the names people called each other across the water. It took the arguments and the songs and the prayers. We sometimes speak of the past as if it is simply waiting to be found. As if the right diver, the right sonar, the right excavation will eventually recover what was lost. But language does not wait in the mud. It does not preserve in salt water. It goes, and it stays gone. And that, perhaps, is the deepest kind of loss the sea has ever swallowed. There is something quietly astonishing about the way ancient people moved things around. Long before written history, before roads of stone or maps on paper, people were trading. Shells found far inland. Obsidian, that sharp, glassy volcanic rock, carried hundreds of miles from where it formed. Amber from the cold north, turning up in warm southern graves. The evidence is clear. People moved. People exchanged. And the routes they used to do it were shaped entirely by the land and water beneath their feet. Many of those routes are now underwater. When sea levels were lower, the world's coastlines looked very different. The shallow continental shelves, those wide, gently sloping edges of land that border most continents, were dry. They were plains, river valleys, and low hills. People lived on them, and people walked across them, carrying goods, following rivers, moving between communities that no longer exist above the waterline. The routes that connected those communities are now buried under tens of meters of seawater. Researchers who study ancient trade patterns have started to notice something. The goods that show up in prehistoric sites along modern coastlines sometimes point toward origins that are now offshore. One idea is that the exchange networks, the paths along which things moved, ran through regions we can no longer easily survey. The source communities, the stopping points, the river crossings. Some of them may be sitting on the seafloor right now. Doggerland is a good place to sit with this thought. That wide plain once connected Britain to continental Europe across what is now the southern North Sea. It was not a barren place. There were rivers, wetlands, forests, and almost certainly people living in dense, productive communities. Those communities would have been connected to each other and to groups further inland. When the water rose, the connections did not simply vanish, they shifted. But the earlier roots, the ones that ran through Doggerland's heart, went under. Some researchers wonder whether the amber trade, one of the oldest long-distance exchange networks we know of in Northern Europe, originally ran partly through Doggerland before the flooding. The evidence is incomplete. We can trace amber from the Baltic coast turning up in graves across Europe. But the middle sections of those routes are hard to reconstruct when the land they crossed is gone. It is a quiet gap in the record. The same question arises in the Indian Ocean world, the Gulf of Combat, where the possible remains of ancient Dwarka have been reported in murky, sediment-heavy water, sits at the edge of a region that was once much larger. The rivers that flow into that gulf would have been longer, reaching further across dry land. River valleys are natural corridors for movement. They guide people, animals, and goods. If communities existed along those drowned river valleys, they were almost certainly connected to each other. The trade that flowed between them would have followed the water, and the water is now the sea. The Aegean is another place where this plays out. Pavloptri, the submerged Bronze Age settlement off the southern coast of Greece, sits in a region that was densely networked during antiquity. The Aegean was a busy sea even in ancient times, and the communities around it traded obsidian, pottery, metals, and grain across open water. But the coastlines those traders launched from were not always the coastlines we see today. Some of the harbors, some of the beach landing points, some of the small coastal villages that served as waypoints, they are gone beneath the water. The trade happened. The routes existed. Parts of the infrastructure that supported them may still be down there. What makes this genuinely hard to resolve is that underwater archaeology is slow, expensive, and limited by visibility and depth. A submerged road or a line of stone anchors on the seafloor can be missed entirely if a survey line runs 50 meters to one side. Sonar helps, but it gives a blurry picture. Sediment covers things. Currents move things. The sea is not a still archive. There is also the question of what we are even looking for. A trade route does not always leave a dramatic ruin. It might leave a scatter of broken pottery. A few worked stones near a river mouth, the remains of a small shelter used by travelers moving between larger settlements. These are subtle signatures, and they are easy to overlook even on dry land. Beneath the sea, they are harder still. So the roots existed. The goods moved. The connections between ancient communities were real and sometimes stretched across hundreds of miles. How much of that network is now resting quietly on the continental shelf, waiting, is a question that remains very much open. There is a simple reason most of us have never seen a sunken city. It is not that the ruins are too deep. It is not that they are too far from shore. It is that the sea is very good at hiding things, and it has had a very long time to practice. When a coastline sinks beneath the water, the process of burial begins almost immediately. Sediment, the fine particles of sand, silt, and clay that drift through the water column, begins to settle. It settles on flat stones. It fills in doorways. It covers the edges of walls until only the tops remain visible, and then it covers those too. Given enough centuries, a whole settlement can vanish beneath a soft, gray blanket of mud. The ruins are still there. They are simply no longer visible. This is one reason underwater archaeology is so difficult. The sites that are easiest to find are the ones that were buried quickly and then left alone. Pavloptri, the ancient settlement off the southern coast of Greece, survived for thousands of years beneath the Aegean, partly because the sediment around it stayed relatively calm. The outlines of its streets and buildings are still readable on the seafloor. But many other sites were not so lucky. Currents shifted. Storms stirred the bottom. Sediment piled up over centuries until the evidence was buried far too deep for a casual survey to detect. The depth of burial varies enormously from place to place. In some shallow coastal areas, ruins might sit under just a thin layer of sand. A storm can uncover them. Another storm can bury them again. Archaeologists working in these zones sometimes describe finding a site one season and returning the next to find it completely obscured. The sea gives and takes back on its own schedule. In deeper water, the situation is different. Below the reach of most wave action, sediment tends to accumulate slowly and steadily. A site buried under several meters of deep water sediment might be extraordinarily well preserved. Organic materials, wooden objects, even food remains can survive in low oxygen environments where decay slows almost to a stop. But finding that site in the first place requires knowing roughly where to look. And for most of the world's submerged coastlines, we simply do not know where to look. There is also the question of what the sea itself does to stone over time. Salt water is corrosive. It works its way into cracks and expands when temperatures change. Biological organisms, sea urchins, mollusks, boring worms, drill into rock surfaces and slowly break them apart. A stone wall that was clearly shaped by human hands might, after several thousand years of submersion, look far more ambiguous. The sharp corners soften, the dressed surfaces pit and erode. This is part of why the debate over sites like the Yonaguni Monument off Japan remains so open. Even researchers who study the site directly disagree about whether its angular terraces and flat surfaces reflect human work, or simply the way certain types of rock fracture naturally under pressure. The sea has had time to blur the evidence in both directions. Biological growth adds another layer of concealment. Coral in warmer waters is a particularly effective cover. It grows over stone structures and eventually encases them entirely. Some researchers believe there are ruins along tropical coastlines that are now so thoroughly encrusted with coral that they would be nearly impossible to identify without very close inspection. The coral itself becomes a kind of archive. It records the history of the structure beneath it in its growth rings, but it also makes the original stonework almost impossible to see. Then there is the movement of the seafloor itself. The ocean bottom is not static. Tectonic activity, the slow grinding and shifting of the great plates that make up the Earth's crust, can tilt, crack, or bury sections of the seafloor over geological time. A site that was once in shallow water might be pushed into a trench. A site that was once accessible might now be covered by a layer of volcanic material from an ancient eruption. Some researchers wonder whether entire stretches of submerged coastline have been altered so significantly by tectonic movement that the original geography is now almost unrecognizable. All of this means that the absence of evidence is not the same as evidence of absence. The fact that we have not found ruins in a particular stretch of seafloor does not mean the ruins are not there. It may simply mean the sea has done its work well. It has covered, corroded, encrusted, and buried. It has been patient in a way that human attention rarely is. And somewhere beneath all of that sediment and salt and slow biological growth, the question of what lies hidden remains, for now, beautifully and quietly open. There is a kind of light that travels through shallow water and bends. It scatters. It fans out in pale blue-green ribbons across the seafloor. Divers know this light well. It is soft and diffuse, and it makes everything below the surface look a little dreamlike, a little uncertain. For most of human history, that uncertain light was all we had. If something lay beneath the waves, we could only find it by accident, by touch, by luck. That has changed. Not completely, and not as fast as we might hope, but it has changed. Sonar is one of the tools that shifted things. The word itself comes from sound navigation and ranging. A sonar device sends pulses of sound down through the water. Those pulses bounce off whatever lies below and return to the surface. The time it takes for them to come back tells researchers how deep something is. The pattern of the returns tells them something about its shape. A flat, sandy bottom returns one kind of signal. A hard, angular structure returns another. Sonar does not see the way eyes see. It listens, and what it hears sometimes is the outline of something that should not be there. Multi-beam sonar, which sends out many pulses at once in a wide fan, can map large stretches of seafloor in a single pass. Researchers have used it to find features that look, from above, like walls, like platforms, like the kind of regular geometry that nature rarely produces on its own. Whether those features are truly human-made is another question entirely. That question is harder to answer from the surface, but sonar gives researchers a reason to look more closely. Satellite imagery adds a different kind of light to the search. Satellites carry sensors that detect not just visible light, but also infrared and other wavelengths that human eyes cannot see. In shallow coastal water, these sensors can sometimes pick up what lies just beneath the surface. The ruins at Pavloptri, off the southern coast of Greece, were known to researchers for decades, but it was only when more detailed survey work combined older maps with newer remote sensing that the full scale of the settlement became clearer. Streets, courtyards, and what appear to be building foundations spread across the seafloor in a pattern that looks, to many researchers, unmistakably like a town. Still, the debate does not go away. Some researchers argue that what looks like a street from above might be a natural fracture in the rock. Limestone, in particular, breaks in straight lines. It forms flat shelves. It erodes in ways that can mimic the geometry of human construction. The Yanaguni Monument off the coast of Japan is perhaps the most discussed example of this problem. Some researchers look at its terraced steps and right angles and see the work of human hands. Others look at the same structure and see a natural formation shaped by the way rock fractures along clean plains. The sonar data and the satellite images do not resolve this. They only sharpen the question. There is also the problem of depth and clarity. Light, even the scattered blue-green light of shallow water, does not reach far. Below about 200 meters, the ocean is dark. Sonar can still map the shape of things down there, but the resolution gets coarser. The detail fades, and most of the coastlines that were above water during the last ice age, roughly 20,000 years ago, now sit under anywhere from a few meters to well over 100 meters of water. Some of the most interesting areas to search are also the hardest to see clearly. Satellite radar has opened one more possibility. Synthetic aperture radar, which bounces signals off the Earth's surface from orbit, can sometimes detect buried or submerged features by measuring tiny differences in how surfaces reflect those signals. Researchers have used this technique to find ancient riverbeds buried under desert sand. Some wonder whether similar approaches might one day reveal drowned river valleys or submerged settlement patterns along coastlines that have never been surveyed by divers. The idea is still largely experimental. The results so far are suggestive rather than conclusive. What all of these tools share is that they extend human perception into places where human eyes cannot easily go. They translate the invisible into something we can study, but translation always loses something. A sonar map is not the same as standing on the seafloor and running your hand along a stone wall. It is a shadow of a shape, a signal bounced back from the dark. The light we send down into the water comes back changed. It carries information, but it does not yet carry answers. And so the search continues, one pulse at a time in the quiet deep. There is a story told in the islands of the Pacific. The elders speak of a great land that once stretched far to the west. It was green and wide. People lived there for many generations. Then, slowly, the sea came. The water rose. The land shrank. And the people who remained carried the memory of what was lost into every song they sang afterward. This kind of story appears in cultures all over the world. It shows up in the myths of coastal peoples from Greece to India to the Americas. A great flood, a drowned homeland, a world that slipped beneath the waves. For a long time, scholars treated these stories as pure imagination. They were seen as moral tales or dreams, or the work of storytellers who wanted to explain the power of the sea. But some researchers now wonder if at least some of these stories are something else entirely. They wonder if certain flood myths are not invented at all. They wonder if they are memories, very old memories passed from parent to child across hundreds of generations, of real events that really happened. This idea is genuinely contested. Many scholars remain cautious. A story changes every time it is told. Over thousands of years, a real event could become unrecognizable. Details shift. Meanings change. What begins as a memory of a flooded coastline might end as a tale about angry gods and punishment. The original event, if there was one, may be buried too deep to find. And yet, the timing is striking. The great rise of sea levels after the last ice age happened roughly between 20,000 and 6,000 years ago. During that long stretch, coastlines around the world changed dramatically. Vast plains flooded. Shallow seas filled in. Land that people had walked on for centuries disappeared beneath the water. These were real events. They happened on a scale that would have been impossible to ignore. Some researchers who study oral traditions, the spoken stories passed down through generations, have looked carefully at Aboriginal Australian myths. These are among the oldest continuous oral traditions on Earth. Some of those stories describe specific places where the sea once was not. They describe land that is now underwater. When researchers compared the locations in the stories to maps of the ancient coastline, some of the details matched. The places described as once dry land are, in fact, now submerged. One careful study suggested that some of these stories might preserve memories of events that happened more than 10,000 years ago. That is a remarkable idea. It is also one that many researchers approach with caution. Proving that a story is a memory of a real event is very difficult. The match between a myth and a geological feature might be a coincidence. The story might have been updated over time to match the landscape as it changed. The researchers who study this are careful to say that the evidence is suggestive, not conclusive. Still, the question stays open. If oral traditions can preserve accurate geographical information across 10,000 years, that changes how we think about ancient peoples. It suggests a kind of knowledge keeping that we have perhaps underestimated. It means that stories might be data, not always, not reliably, but sometimes. In India, ancient texts describe a great city called Dwarka, the legendary home of the god Krishna. The texts say the city was swallowed by the sea. For centuries, this was treated as myth. Then, in the shallow waters of the Gulf of Combat, divers and researchers found stone structures on the seafloor. The structures are real. What they are is still debated. Some researchers believe they are the remains of an ancient settlement. Others argue the formations are natural. question has not been settled, but the overlap between the myth and the physical location is hard to ignore. Whether or not the structures are man-made, the sea did rise in that region. Land did flood. People did live along those ancient shores. The myth and the geology are pointing at the same general truth, even if the details remain unclear. This is the quiet possibility that sits beneath so many flood stories. Not that they are literal history, not that every detail is accurate, but that somewhere inside the story there may be a real coastline, a real moment when the water came, a real group of people who watched it happen and found a way to remember. The sound of that memory is very faint now. It has traveled a long way to reach us. We cannot be certain what it is telling us, but it is worth listening to slowly in the quiet before sleep. There is a story that has lasted more than 2,000 years. It comes from a Greek philosopher named Plato, who wrote it down around 360 BCE. He described a great island civilization, powerful and prosperous, that sank beneath the ocean in a single day and night. He called it Atlantis. Most scholars today believe Plato invented the story. They think he built it as a kind of thought experiment, a way to explore ideas about pride and collapse, and what happens when a society reaches too far. That reading is very common, and there is real support for it. Plato was known for writing stories that carried deeper meanings. His other works are full of invented places and invented people used to make philosophical points. But some researchers pause at the numbers Plato gave. He did not just describe Atlantis in vague terms. He gave measurements. He described a city laid out in concentric rings, alternating land and water with precise dimensions. He placed it 9,000 years before his own time. He described its location as beyond the Pillars of Hercules, which is the ancient name for the Strait of Gibraltar, the narrow passage between the Atlantic Ocean and the Mediterranean Sea. Those numbers are interesting, not because they prove anything, but because they raise a question. Why would a philosopher inventing a simple moral fable bother with such specific geometry? Some researchers wonder whether Plato was working from older stories, stories passed down through generations, stories that carried a faint memory of something real. Others say the numbers are simply part of the fiction, chosen to make the story feel solid and believable. Here is where the mathematics of sea level becomes quietly fascinating. 9,000 years before Plato's time would place Atlantis roughly 11,000 years ago. That date sits very close to the end of the last ice age. It sits close to the period when sea levels were rising fastest, when coastlines were changing within living memory, when entire stretches of land were going underwater in ways that real people witnessed. The timing is not proof of anything, but it is a strange coincidence that the date Plato chose aligns so closely with the most dramatic period of coastal flooding in recent human history. One possibility is that this is exactly what it looks like: a coincidence. Another possibility, which some researchers find worth exploring, is that very old stories about flooding and lost lands circulated around the ancient Mediterranean world, and Plato shaped one of those stories into his philosophical tale. There are real candidates that some have proposed over the years. The island of Santorini in the Aegean Sea was partly destroyed by a massive volcanic eruption around 1600 BCE. That event was real and well documented. Some researchers have suggested it inspired the Atlantis story. Others point out that the timeline doesn't match Plato's numbers, and the geography is wrong. Santorini is inside the Mediterranean, not beyond Gibraltar. Others have looked at the shallow seafloor beyond the Strait of Gibraltar, searching for any structure that might match Plato's description. Nothing conclusive has been found. The seafloor there is deep, and the geology does not obviously support the idea of a large sunken island. Still, only a small fraction of that seafloor has been carefully mapped. What the Atlantis story does, regardless of whether it describes a real place, is point toward something true. It points toward the fact that the ancient world knew about lost lands. People in Plato's time had access to older stories, older maps, older traditions. They lived in a world where the sea had swallowed coastlines within the span of human memory. The idea of a civilization lost beneath the water was not absurd to them. It was, in some ways, simply an extension of what they already knew had happened to smaller places. The elegant thing about Plato's numbers is not that they solve the mystery. It's that they sit in such an interesting place. They are specific enough to invite real comparison with what we know about sea level history. They are vague enough that no single location fits perfectly. They are old enough that the original source, if there was one, is far beyond our reach. Some mysteries stay open not because we lack the tools to solve them, but because the evidence dissolved long ago. The story of Atlantis may be one of those. A real memory shaped into philosophy, passed through centuries, and now impossible to trace back to its origin. Or it may be exactly what most scholars say it is. A beautiful, invented story that happened to ask the right questions. Both possibilities are worth sitting with quietly as the night settles in around you. There are places along the coast where, at very low tide, the sea pulls back just far enough to reveal something strange. Dark, twisted shapes rise from the sand. They look almost like the stumps of old trees, and that is exactly what they are. These are sunken forests, ancient woodlands that once stood on dry ground, now resting beneath the waves. You can find them off the coasts of Wales and Cornwall and Brittany in France. You can find them in the Baltic Sea and along the shores of the eastern United States. They are not rare. They are scattered across the shallow edges of the world's oceans, quiet and patient, waiting for the tide to go out. The trees in these forests are often oak or pine or hazel. Some of them are thousands of years old. Their roots are still in place. Their stumps still stand where they grew. The wood has been preserved by the cold, low-oxygen mud that covered them when the sea moved in. In some places, the peat around the stumps still holds seeds and pollen and the remains of insects that lived in those long ago woods. What makes these forests so remarkable is not just that they survived. It is what they tell us about the land that once existed here. These trees did not grow underwater. They grew on solid ground in real forests under open sky. The fact that they now sit below the tide line means the land itself sank, or the sea rose, or both. And and the evidence suggests it was mostly the sea. After the last ice age ended, roughly 12,000 years ago, the great ice sheets that covered much of the northern world began to melt. All that water had to go somewhere. It flowed into the oceans. Sea levels rose slowly at first, then faster, then slowly again, in pulses that are still not fully understood. Some researchers estimate the sea rose by more than 100 meters over several thousand years. That is a staggering amount of water. The forests drowned, the meadows drowned, the river valleys and the low coastal plains drowned. Everything that people had built or walked across or hunted through in those wide, flat lands along the ancient shore went under. What is harder to understand is how gradual or how sudden any of this was. The average rise was slow by human standards, perhaps a few millimeters per year in some periods. But some researchers believe there were episodes of much faster change, times when the meltwater surged and the sea climbed more quickly than usual. Whether those surges were fast enough to be noticed within a single human lifetime is still an open question. The sunken forests give us one way to think about this. When you look at the spacing of the stumps and the way the peat layers sit around them, you can sometimes read a kind of record. The trees grew. The ground became wetter. The trees died. The peat formed. Then the sea came. Each layer holds a little piece of the story, but the story is never complete. The record is always partial. Some of these drowned landscapes also hold signs of human presence. Footprints pressed into ancient mud, hearths filled with charred wood and animal bone, flint tools scattered across what was once a forest floor. These are the traces of people who lived in places that no longer exist as land. They walked through those forests. They lit fires there. They left things behind. What we do not know is how much more is out there, still buried, still waiting. The shallow continental shelves around the world cover enormous areas. Much of that seafloor has never been closely examined. The surveys that have been done are incomplete. The tools for finding buried organic material under meters of sediment are still being developed and refined. One thought that stays with you when you consider the sunken forests is how thin the margin really is. The conditions that kept those ancient coasts above water were not guaranteed. They depended on the balance between ice and warmth, between the weight of water and the shape of the land. When that balance shifted, the forests went under, the hearths went under, the paths between the trees went under. The world that exists right now, with its coastlines and its harbors and its low-lying plains, is also sitting within a particular balance. The sea is not finished moving. It never really was. The sunken forests are a reminder that what feels permanent is often only temporary, held in place by conditions that can and do change. The stumps stand in the shallows. The tide comes in. The tide goes out. And the old wood waits, as it has waited for thousands of years, for someone to come and ask what it remembers. Somewhere long ago, a person stood at the edge of the water and watched the sea come in. Not in a single wave, not in a single storm, but slowly, over years and decades, the shore they knew kept moving back. The land their parents had walked was gone. The place where they had gathered food, built fires, raised children, it was slipping beneath the surface. Little by little, season by season. We do not know who that person was. We do not know what they said, or thought, or believed about what was happening. That is one of the deepest silences in all of human history. And it is a silence that researchers are still trying to hear. The people who lived through the great sea level rise after the last ice age left almost no written record. Writing had not yet been invented in most parts of the world. What they left behind were tools, hearths, bones, and the occasional stone structure, now buried under cold water and silt. From those fragments, archaeologists are trying to piece together something remarkable. What daily life looked like on coastlines that no longer exist, but the gaps are enormous. Even the most careful excavation of a submerged site can only recover a small portion of what was once there. Organic materials, wood, cloth, leather, plant fiber, rarely survive thousands of years underwater. What remains is often stone, and stone is patient but quiet. It tells you something was built. It does not always tell you why, or by whom, or how long it stood before the water came. One of the open questions that researchers return to again and again is this: how quickly did those ancient communities understand what was happening to their coastlines? The sea did not rise at a steady, predictable pace. There were periods of faster change, sometimes linked to the sudden collapse of ice sheets far to the north. Some researchers think certain communities may have experienced flooding that felt sudden and catastrophic within a single lifetime. Others suggest the change was gradual enough that most people simply moved inland, generation by generation, without any single dramatic moment of loss. Both ideas may be true in different places at different times. The evidence is incomplete, and the picture is different depending on which coastline you study. There is also the question of memory. Oral traditions, stories passed down by voice across generations, can sometimes preserve the shape of real events. Some researchers believe that certain flood myths from coastal cultures around the world may carry the echo of actual inundation events from thousands of years ago. But separating genuine memory from symbolic storytelling is extraordinarily difficult. A story about rising water might describe a real flood. It might describe something else entirely. The line between history and metaphor blurs quickly across that many generations. What we do not yet know is whether any specific myth can be reliably traced to a specific submerged landscape. Some researchers think the connection is real and worth pursuing. Others are more cautious, pointing out that flood stories appear in so many cultures that they may reflect universal human experience rather than any single shared event. Then there is the question of what we have not yet found. The majority of the world's submerged coastlines have never been surveyed in detail. The technology to do so exists, but the ocean floor is vast, and the resources available for underwater archaeology are limited. There are almost certainly submerged sites out there, perhaps many of them, that no modern eye has ever seen. They sit in the dark, under layers of sediment, waiting. Some researchers believe the most significant discoveries are still ahead of us. They point to regions like the continental shelves of Southeast Asia or the submerged plains off the coast of northwestern Australia. As as places where ancient populations may have lived in large numbers during the Ice Age, when sea levels were far lower. Those areas have barely been explored. Others are more measured. They note that even when sites are found, interpreting them is slow, careful work. A submerged structure does not announce itself. It must be mapped, sampled, dated, and compared against everything else we know. That process takes years, sometimes decades. What remains at the center of all of this is a human question more than a scientific one. There were people here. They lived full lives on land that is now sea. They watched the water rise, or their children did, or their children's children. They carried something forward, some knowledge, some story, some memory of the place that was lost. We are still trying to find out what that was. And the ocean, as always, keeps its own counsel. The sea is rising again. It has done this before many times across the long history of this planet. But something about this particular moment feels different to the researchers who study coastlines for a living. The question they sit with is not only about the past. It is also about what is happening right now, quietly, at the edge of every shore. Tidal gauges around the world have been recording sea levels for well over a century. The numbers they show are slow but steady. The ocean is creeping upward a little more each decade. Most researchers agree on that much. What remains open is exactly how fast this will continue and what it will mean for the coastlines we live on today. Here is the part that connects directly to everything we have been exploring together tonight. The same process that drowned Doggerland, that swallowed the ancient shores of Dwarka, that buried Pavloptree under the blue Aegean water. That process is still running. It never stopped. The great flooding that began at the end of the last ice age slowed down, but it did not end. The water is still finding its level. Some researchers estimate that sea levels today are still rising at a pace that, over centuries, will reshape familiar coastlines. Low-lying coastal cities, shallow harbors, beaches where people walk every morning. All of these sit at the edge of the same slow transformation that erased the settlements we have spent this whole episode wondering about. One theory holds that future generations will look back at our current coastlines the way we look back at Doggerland, as a place that existed, that was lived in, and that is now gone beneath the water. That thought is not meant to alarm. It is simply the long view. The earth has always been in motion. What makes this moment genuinely interesting to underwater archaeologists is a kind of strange double awareness. On one hand, rising seas will eventually cover new land, creating future underwater sites that researchers thousands of years from now might one day explore. On the other hand, rising seas are right now threatening some of the submerged ruins that already exist. Warmer, more acidic water can erode ancient stone. Stronger storm surges can scatter artifacts that have rested undisturbed for millennia. The ruins of Heracleion off the Egyptian coast, the stone platforms at Yonaguni, the ancient harbor walls still resting in shallow water around the Mediterranean. All of them sit in a sea that is slowly, quietly changing around them. Some archaeologists argue that urgency is the right word for underwater survey work right now, not because the ruins will vanish tomorrow, but because the window for careful, undisturbed study may be narrowing in ways that are hard to predict. Others push back gently on that framing. They point out that the sea has always been a dynamic place, and that many submerged sites have survived thousands of years of wave action, current, and sediment shift already. The ruins are more resilient than they might appear. Both views hold something true, and the honest answer is that no one knows exactly how each site will fare. There is another layer to this worth sitting with quietly. As sea levels rise, some new coastlines are being exposed in unexpected places. Melting glaciers in the far north are uncovering land that has been buried under ice for tens of thousands of years. Some of that land may hold its own archaeological secrets, traces of people or animals or environments that no one has studied yet, simply because the ice was always in the way. The planet is not only losing edges. In some places, it is gaining them. So the story of lost civilizations beneath the sea is not a closed chapter from the distant past. It is an ongoing process, still writing itself. The coastlines of today are the potential underwater ruins of some far future. The ice retreating in the north may be uncovering the hidden past of some earlier world, and the shallow seas where ancient people once walked, built, and lived are still holding their secrets in the silt, waiting for the right question, the right sonar pulse, the right careful hand to brush the sediment away. What the sea takes, it keeps for a very long time. What it reveals slowly, on its own schedule, in its own time. The water has been rising and falling across this planet for as long as there has been water to rise and fall. We are somewhere in the middle of that story. We do not know yet which chapter we are in, or how many remain. There is a quiet kind of humility that comes from standing at the edge of the sea at night. The water is dark. The horizon is gone. You cannot tell where the ocean ends and the sky begins. And somewhere beneath that surface, at depths we have barely touched, there may be walls. There may be floors. There may be the worn edges of doorways that people once walked through every morning of their lives. We may never find all of them. That is not a failure. It is simply the scale of the question. The ocean covers more than 70% of this planet. We have mapped less of the seafloor than we have mapped the surface of the moon. The tools exist to go deeper, to scan wider, to listen more carefully to what the sediment holds. But the ocean is vast in a way that resists easy summary. Even if we surveyed every shallow shelf, every drowned river valley, every submerged coastal plain, we would still be working through centuries of silt and salt and silence. Some things dissolve. Wood rots. Cloth vanishes. The soft materials of daily life, the baskets, the clothing, the food, the stories told aloud, those are gone. What remains is stone, and sometimes bone, and sometimes the faint chemical traces of a hearth that burned 10,000 years ago. Even those traces are fragile. Currents move sediment. Trawling nets drag across the bottom. The sea does not preserve the past the way a dry cave does. So there is a real possibility that some of what was lost is simply gone, not hidden, not waiting, gone. That thought is worth sitting with for a moment. And yet, the sites we have found suggest that the ones we have not found may be extraordinary. pavlope tree in the Aegean gives us streets and thresholds. Heracleion off Egypt gives us statues and temple walls. Dwarka in the Gulf of Combat gives us geometric shapes in the sediment that some researchers believe are worked stone. Each discovery was a surprise. Each one reminded us that the absence of evidence is not the same as evidence of absence. There is a theory in archaeology, a quiet, careful one, that the most significant prehistoric settlements were built near water, near rivers, near lakes, near coasts, because water meant food, trade, and travel. If that is true, then the places where people most often chose to live are precisely the places the sea has most thoroughly swallowed. The richest chapters of early human coastal life may be the ones written in the deepest mud. Some researchers believe we are only at the very beginning of understanding this. Sonar technology improves every few years. Underwater drones can now hold position in currents that would have made earlier surveys impossible. The chemistry of ancient sediment can now be read in ways it could not a generation ago. There is genuine reason to think that the next 50 years of underwater archaeology will change what we know about the ancient world. But other researchers are more cautious. They point out that distinguishing a natural rock formation from a worked stone is genuinely hard underwater. The Yonaguni Monument off Japan is still debated. Some geologists look at its terraced steps and right angles and say that sandstone fractures that way on its own. Some archaeologists look at the same shapes and say that nature alone does not explain them. Both groups are serious. Both groups are careful. The question remains open. That is the honest position, not certainty in either direction. Just the open question, held gently. What we may never know is the full shape of the world as it was when the ice was still melting. We may never know the names of the people who stood on those coasts and watched the water come. We may never know what they called the sea, or what stories they told about the horizon, or whether they believed the land would return. We carry something of them, though. The calcium in our bones was built from the food that grew in soils like theirs. The instinct to build near water, to settle where the land meets the sea, is very old. It runs through every coastal city on Earth today. When we look at a submerged wall through the green murk of shallow water, we are looking at something that was once as ordinary as a street corner. Someone leaned against that wall. Someone walked past it without thinking. The sea took it. The sea keeps it now. And we are left with the question, which is perhaps the most honest place to be. Not knowing is not the same as not caring. It is simply the truth of where we stand, at the edge of something much older and much larger than ourselves. And so we arrive here, at the quiet end of a long and wondering night. We have moved through a great deal together. We walked the edges of coasts that no longer exist. We stood in our minds on the shores of Doggerland, that wide and grassy plain that once stretched across what is now the North Sea. And we watched the water creep in slowly over centuries. We thought about the people who lived there, who fished and built fires and raised children, and who may have told their grandchildren about the land that was already going under. We visited Pavloptri, that quiet Greek town resting on the seafloor in the Aegean, its streets still laid out in a pattern that speaks of ordinary life. We wondered about Dwarka, about Yonaguni, about Heraclean, about all the stone and mud and silence waiting beneath the waves. None of it is fully answered. That is the honest truth of this night. We do not know with certainty which structures were built by human hands and which were shaped by water and time alone. We do not know how many settlements still wait beneath the silt, unseen, unmapped, unvisited by anyone in 10,000 years. We do not know what languages were spoken on those drowned shores, what songs were sung, what names people gave to the stars above them. Those things may be gone forever, or they may be preserved somewhere in some layer of mud at the bottom of a shallow sea, waiting for the right instrument to find them. That question will outlast this night. It may outlast us entirely. But there is something peaceful in that, something restful about a planet that still holds its secrets close. Think of the ocean right now, wherever you are. It is out there in the dark, vast and slow, and breathing with its tides. The moon is pulling at it gently, the way it always has, the way it did when those ancient shores were still above water. The surface catches a little light, silver and shifting, Below the surface, the water deepens into blue, then into black, and somewhere in that darkness, far below the reach of any light, the seafloor holds what it holds. Stone walls, perhaps, old hearths, the ghost of a doorway, or simply rock shaped by pressure and time into something that only looks like human work. We cannot know tonight, and that is all right. The earth is very old. It has seen ice cover half the land and then retreat. It has watched seas rise and fall and rise again. It has held the weight of glaciers and the warmth of long summers. It has done all of this without hurry, without alarm, in its own deep time. And it will go on doing so long after every question we have asked tonight has either been answered or quietly forgotten. You are part of that same slow world. Your body is made of the same minerals that line the seafloor. The water in you is the same water that has moved through clouds and rivers and ancient seas for billions of years. You are not separate from this story. You are woven into it, the same way a stone wall is woven into the silt that covers it. So, let the questions rest for now. Let the drowned cities stay where they are, quiet in the dark water. Let Doggerland sleep under the North Sea. Let the Yonaguni Monument sit in its cold current, patient and still, neither confirming nor denying what it is. Let Heracleion rest in its silt off the Egyptian coast, its statues tilted and calm. The archaeologists will go back. The sonar will sweep again. The divers will descend. And slowly, over years and decades, some of the mystery will give way to understanding. Some of it, perhaps, never will. For tonight, it is enough to have wondered. It is enough to have let your mind drift out over the water, to have imagined those old shores and the people who stood on them, looking out at the same sea we look at now. They wondered too, in their own way, about what lay beyond the horizon, about what the water was hiding, about how long the land beneath their feet would hold. We are still asking the same questions. That is not a failure. That is what it means to be curious on a planet that is older and stranger, and more beautiful than any of us can fully take in. The ocean breathes. The tide moves. The world turns slowly in the dark. Rest now. Subscribe for a brand new Earth topic every night. One tap and something wonderful is waiting for you tomorrow. Sweet dreams.